Welcome to another great O'Reilly webcast. Rapid prototyping web applications using Node.js and MongoDB with Jason Kroll. For a list of all our free webcasts and to sign up for our weekly newsletter, go to webcast.o'reilly.com.
I just want to thank everybody again for attending. As you can see, this is going to be a talk about rapid application development. So I did want to just preface the talk by saying I do have a book that I've written recently. It was published back in September, and the top one there is Web Development with MongoDB and Node.js. That book covers pretty much the full spectrum of writing a complete interactive application using Node, Express, and MongoDB specifically. The purposes of this talk is really to just see how quickly we can build an app using these tools without going into too much, low-level detail on the actual process. The book itself, though, goes into great detail, and it's obviously, it would take much longer than an hour that I have to be able to go over everything. The other book I have there is just an ebook that's available on Amazon, and that's just kind of a breakdown and an anatomy of a full web application, including the front end using Backbone. I do want to warn you that because this is a prototype, it means the code is certainly not production ready. I've sort of put best practices taking a back seat because it was more important that I kind of emphasize, the topic that we're talking about versus going to a lot of detail about, common and best practices. There's no validation on any of the input fields that we have in the app that we build, and there's definitely no security. Again, this is kind of like a bootstrap, get the app up and running as quick as possible kind of thing. So kind of take that with a grain of salt. So the application that we're going to build, we want to be able to quickly prototype a dynamic application. So we want it to be data-driven. We want it to persist data. We want users to be able to log in, and whatever they do in the application, remember that the next time they come back. The key to this application is that we need a web server. The web server is going to be powered by Node and primarily with Express.js. Our data needs to be stored somewhere, so we're going to use MongoDB for that. Because we're using Node, we're going to use the Node.js driver for MongoDB. All of the HTML that we're going to serve, we're going to use handlebars.js as our view rendering engine. And finally, we're going to wrap the entire application using Twitter's Bootstrap, which is just an HTML framework for kind of designing pages using a very consistent style guide and UI without having to actually worry about that stuff. In conjunction with Bootstrap, we'll use a little bit of Font Awesome, which is really just a font library of icons. So pretty much all of the standard web-based icons that you've probably seen throughout typically will come from a package like Font Awesome, or Bootstrap itself has something as well. So this is the prototype that we're going to make, and I can do a quick demo of the actual application now so you can see it running. So the first thing that users will be able to do is actually log in. And also register if they've never logged in before. The point of the application is that it's just kind of a queue of movies that I'm either interested in watching or planning on watching in the future if they're not released yet. The movies that are listed here, I can search through the moviedatabase.org. So as I start typing, a list of matches will show up. I can select one and add it. In this case, I've already added that movie, but you can see it actually added twice. So that's kind of an example of validation not really being a thing in this app. And I can mark a movie as that I've seen it and it's already been watched. That's pretty much the gist of what the application actually is and what it does. So here's sort of the key takeaways of that. We need to be able to track a list of movies specific to my account that I'm interested in watching. We need to perform a real-time search against a real API that's live. We're going to add data to our own database using the data from that API. We want to have a little bit of interactivity so that we can mark a movie as watched, and all of this needs to be tracked via a unique login for each individual user so that it actually works for each person that goes. So with that said, we're going to actually kind of dig in here and see if we can start trying to build this thing. The first thing we need to do is prepare our actual web server. Because it's a web server, it has some pretty standard functionality that it has to do. It needs to support cookies, user sessions, standard logging, things like that. Everything that you'd expect a web server to do, it needs to do. it also needs to be able to connect to a MongoDB server so that we can pull data, post data, and things like that. All of the HTML that we render needs to be dynamic because it's going to be unique for each person that visits the site. And finally, the web server itself needs to handle the actual endpoints for viewing certain pages and logging in and posting data and things like that. So the first thing that we're going to do pretty much whenever we start any Node application is this sort of handy npm command, which it doesn't look handy because it's like super long. But the gist of what we're doing here is we're doing an npm init, and then we're also installing a number of Node modules that we're going to be using in our application. Once we do that npm install, you can see here it lists a number of things. The first is Express, which is kind of like the key framework that we're using for the Node app. The remainder are a number of middleware that we're going to be using, and I'll be explaining them as we get to the part in the code where we're actually going to be using them. When you do an npm init, it will kind of present you with like a questionnaire where it asks you a number of things about your project. And assuming you just kind of hit enter and use the default value for everyone, which is kind of what I did here, this is pretty much the end result that you'll get. The dependencies list that you see at the bottom half of that screen is all of those Node modules that we installed with that npm install command. Because we used the --save flag on the npm install, it actually edited this package file and listed those dependencies as well as the current version if I hadn't specified a version. So as of the moment that I ran this npm install, the dependencies that are listed there, that's their current version. If I were to install the dependencies later, because the version numbers are marked there, it'll always be that version. So my app will always be functional. It won't change all of a sudden because somebody upgraded one of those dependencies. So okay, let's actually start coding. So here is the project folder that I'm working out of. I've already done my npm install, so you didn't have to sit through the actual download process because it can take a couple minutes. If I listed the contents of the directories, I basically have my package file, which we just looked at, and a Node modules folder, which is the folder that actually houses all of the things that I just installed. So you can see if I list the contents of that folder, everything that we just installed with npm sits there, and that's the full source code for those modules. So if we ever were curious, we can go in and kind of see exactly how one of those works. We can take a look at the package file again, and you can see, again, it's pretty much what you'd expect. So other than that, the actual application folder is empty. So the first thing I'm going to want to do is create a couple folders for the actual project itself. Okay. Actually, before we even do the folders, we're just going to start editing files right away. So here's a blank copy of Sublime I have. The first file that I'm going to edit, we're going to simply name server.js. And the name of that file is sort of a common convention, but it's not a necessary file name. You can call it whatever you want. So let's save that, server.js. Good. And so obviously I just pasted that code in so you didn't have to sit here and watch me horribly type and make tons of mistakes. But the first thing that we're doing at the very, very top of the application, of the server I should say, is we're pulling in some of those Node modules that we required or that we npm installed earlier. So Express, first and foremost, that's going to be one of our most important things that we use. Underscore, because that's just kind of a helpful utility library we can use. And then you can see there's a couple more in there, which I'll get to in a second. The configure and MongoDB are both custom modules that I wrote for this particular project. So instead of using just the name of the module, which was installed, I'm actually doing a dot path sort of setting there because it's actually pulling a local file in my project. And we'll create that in a second. So other than requiring those modules that we're going to be using, the two key most important elements here is that we're configuring our app by calling this configure module from above, and then we're creating a server by telling our app to listen on a certain port. And the port doesn't really matter, but it's something that you'll see that we set via the configure module. Once the server is up and running, we just tell our MongoDB client to connect as well, so that basically with our server running, we have the actual web server running, which is the app variable, the Express variable, And then we also have a connection maintained to our MongoDB server as well. And you can see by the MongoDB connection string here that it's just a local host connection. So I'm actually running MongoDB in another terminal window locally. The path after the host name is just the name of the database that I want to connect to. And the beauty of MongoDB is I can literally type whatever I want here for a database name, and if it doesn't exist, it will just create it automatically. Other than that, I'm just doing some simple console logging so that when I actually run this Node server, I'll see that the server is up and running and what the URL is, and then I'll see that it also maintained a valid connection to MongoDB. The next thing we're going to take a look at is this configure module. Now, the one thing I want to warn you about is that the configure module is probably the largest piece of code that you're going to see in this entire talk, but I don't want that to intimidate you. So let's create a new file, and we're going to paste this in. This is pretty much like a boilerplate piece of code that I use almost for all of my applications. It will grow depending on the complexity of the app that I'm building, but when I'm starting, I pretty much paste this file in verbatim. And really what it's doing is it's pulling in all of the middleware that I'm going to be using with my Express app and then configuring it. So most of the configuration settings for some of these, like body parser, method override, things like that, you can just leave them default. You don't even have to provide a value. But you can see like with my cookie parser and my session middleware, I'm providing like a super secret key, which can pretty much be whatever you want. But again, this entire configuration module is just preparing the server to handle the various middleware tools that I'm going to be using, providing any customized settings that I might need. You can see up here we're setting our app's port to 3000 if it's not already being set by the machine itself. We're telling the app where it can find our views, which are going to be our HTML pages, and what we're using to actually render those views, which in this case we decided to use handlebars. We could have used whatever we want. There's like 100 probably different template rendering engines available to use in Node, and it really is just your personal preference which one you enjoy working with. I personally enjoy handlebars simply because it's identical doing templates on the back end as well as the front end. So I personally do a lot of Backbone apps, and I use handlebars with Backbone as well. So there's never really like a context switch for me to kind of change between which templates that I'm editing. Here I'm actually, again, configuring the handlebars template rendering engine and really just pointing the default layout folder and layouts directory, or I should say the layouts directory and then the actual file that's going to be my layout. And the layout is just kind of like, if you're familiar with like ASP.NET development, it's like a master page, or if you've done PHP, it's just like that sort of main wrapper HTML file that consists of like the bulk of your website shell, and then all of your pages get rendered like inside that page. And we're going to define that later, and you'll see. The rest of this middleware is just doing standard web server-based stuff. Morgan is like a logging library, so all it does is just log to the console whenever you see like activity to your server. Body parser is what we use to handle like form submissions and like JSON posts to our endpoints. Cookie parser lets us actually have cookies, which is important because if we want to have sessions and we want users to be able to maintain a session during the use of their site, we're going to need to be able to store that stuff in a cookie. And then finally, we just use Express's built-in static middleware, which lets us define a folder that we're going to use that's not going to have any dynamic content in it. It's going to be purely for serving up our assets. So it's going to be like our image files, our CSS files, JavaScript files that are for the client. Nothing that's served out of this public folder is really going to go through any other processing other than it's just served to the browser. And then so after we've done all of this configuration, the very last thing we're going to do, and you can kind of see this routes defined up here, it's one of the ones that has a dot in the path, so that's how we know it's going to be our file. The routes is the last thing we do, and we just initialize our routes as an Express router, and that's going to be how we define all of the actual endpoints for the application. So any way anybody's going to hit our server and be able to get to /foo or /bar, we need to define those ahead of time. What happens when somebody types /foo after the URL to your website? what does that do? Where is the logic residing on the server that's actually going to figure something out and serve HTML ultimately from that point, or serve JSON data depending on what you're doing. You can see we're returning the app. So if we switch back to server, what we did was we have our app variable defined as an express, what express returns. We passed that variable into our configure module, did some processing to it, and just kind of spit it back out, but like changed for the better, basically. So with this server file and this, let's save this as configure.js, since that's what we're referring to it as up here. Oops, looks like we put it in a server folder, so I should fix that. And where am I? Oops, hold on one second. Okay, let's see. Okay, that's empty. I'm not sure where my files are being saved to, but that's okay. We'll fix that later. So assuming we save this configure file into a folder called server, and then we named it configure, the other thing here is because we're using our own local files, we don't actually have to specify .js in the file name. Node just assumes that. So we could put .js here if we wanted to, but it doesn't really matter, and it's common convention to not include that, so I'll just take that out. So now we have our server file and we have our configure file. The next thing we need is our routes, because in our configure file, we're referring to this routes object up top here. So we're going to go ahead and make that. So I'll create another new file, and I'm going to name this file routes.js. But first, I will put some code in it. So this is basically our routes, and all it is us just defining ahead of time what endpoints we want our web server to support, and the methods that we support for that particular endpoint. So the first and most obvious is this get on slash, which is really just the root endpoint for our website. So this is really just going to load effectively like the home page. And we want that to be a get, because gets are the standards that browsers are sending whenever they're trying to retrieve data. We're also going to have a slash login URL available, and that's just going to show our login form or prompt. And then we've got a couple post endpoints here as well, which we'll kind of get to as we sort of define those down the road. So once we have our routes defined with our router, we just tell our app to use the router, and then that way it's all tied together nicely. Now you should see sort of a consistent, let me save this file real quick, a consistent theme here, which is now at the top of our routes, we're requiring a controller, which is, again, our file. It's not like a module that we installed through NPM. So what our router is saying is that each route that we define, really, it just expects a callback function as the second parameter here. And we could have just put all of our code for our controller in line here, but that would probably make this file like pretty unwieldy and kind of become a mess and hard to read and debug and things like that. So personally, what I like to do is just define a controller or a folder called controllers where I store all of my actual route logic, and then that way my routes are like super clean and neat, and I can just define them this way, and then I can maintain all of my logic in my controller. So the next thing I'm going to do is define my controller. So let's create another new file, and we'll call this controller.js, and we will put in some code here. So here we basically have another just random node module that we created, and it has a bunch of functions. And each of these functions pretty much corresponds one-to-one with a route that we have defined. So you can see route get slash, we have controller index. And if we look at our index in our controller, it's simply a function that just sends the words index controller to the screen. So if I were to run this app right now and just pull up the home page, I would just see the words index controller on the screen. Likewise, if I pointed to /login in the URL, it's going to execute the show login function. And if we look over here at show login, same thing. It's just going to throw some text up on the screen. So this is just us kind of boilerplating this controller. So we have a placeholder for things, and we know kind of how things are defined and where we're going to need to actually start putting some real logic. Furthermore, our process login and add movie endpoints right now, all they do is redirect to the home page because they're going to be postable endpoints later. So we just put something there so that they actually work if we wanted to test them. So let's see. The only other piece left in our, sort of boilerplating up our server is this little client thingy up here at the top. And that's for, we are going to be frequently making connections to our MongoDB database. And because I didn't want to constantly be opening and closing connections and have all of that extra code that I had to worry about in my controller, I opted to create a module that just opens a connection once and maintains it for the duration of kind of a lifetime of the application itself. So if we take a quick look at that file, which I'll create a new one, and we'll call it Mongo client.js. And let's take a look at that code. So this is a module that is actually wrapped inside of a self-invoking function. And what it's doing is it's basically declaring a local variable called MongoDB. And when we call the connect function, it's going to create a connection object and then save that connection object back onto the module itself, so that whenever we require that module later anywhere in our application, that connection object will always be available to us. We don't have to constantly tell it to connect. So if we look at our server file, you can see this was the only time we called connect, and that was when we first start the server via this app.listen. From here on out, we never have to call connect again. We only need to call the DB function, which is here. And you can see all the DB function does is just return the copy of the connection object that we saved within this module. So that's just kind of like a little tricky thing I made just to make my life a little bit easier. But it should kind of give you like a little taste and appreciation for how easy it is to create your own modules and just require them throughout your application and not really worry about like what's actually going on there. So you can see back on our server, we're requiring our Mongo client up here. And then if we look at our controller, we're requiring, again, the one thing you might notice is I call it client here, and then in server I call it MongoDB. And that actually doesn't really matter. It's just that is, we're just naming variables when we do that. So whatever the require function does in Node, it's always going to return something. And what it returns, you're storing to a variable. So you can call it whatever you want. Perhaps you could criticize that I probably shouldn't have called them something different because it makes it a little confusing. But in this case, I don't think it's all that harmful. Not to be confused with, in the Mongo client itself, we are requiring the actual MongoDB Node.js driver, which is different. And that's another reason that I created this Mongo client. That way I don't have to pull in the MongoDB Node.js driver, Mongo client, connect to it, do all of this kind of housekeeping every time I want to make a connection to the database. Here it's just all encapsulated and I don't have to think about it. So with our controller, this is pretty much going to be the brains of our application. This is where we're going to store all of the logic that needs to do any kind of thinking when anybody does anything on a site. If they try to log in, if they're trying to save a movie or get their list of movies or whatever they're doing. So with us kind of boilerplating up these endpoints, the only other thing I did was require these two modules at the top. And besides the client, which I just explained, request is just an NPM a Node module that's pretty popular, and it's really just for making HTTP requests to anything really. And I'm particularly going to be using it to make requests to the movie database API, the third-party API. So if you're ever going to be making any kind of API type requests in your application, requests by its namesake, it's pretty much going to be the module that you're going to wind up using. So with all of that, let's see, we have our server kind of prepared. It's ready to be run, and I can actually because the files that I'm saving are actually saving to the wrong place. It's not going to run if I try it, but I can do it in another window, and I can show you. Let me share this again. So here we have a copy of the app that I have running. So you can see I have got my server folder, my server.js, and if I look at my server folder, it's got my configure module that I wrote, my controller, my Mongo client, and my routes. So if we tried to run this, which simply we just type node server.js, hopefully this will work. So you can see it logged that the web server was up, and then it subsequently logged that it's connected to MongoDB. At this point, I can open this URL right in my browser, and I'm pretty much only going to see index controller, the text that we're currently outputting in our controller. It's not going to actually do anything. So let's cancel that. And let's go back to the slide real quick here. So we've got our server kind of wired up. It's running. It looks like it's listening to MongoDB, but it's not actually doing any kind of thinking, and it's certainly not displaying anything on the screen. So the next thing we need to do now is wire up some actual HTML in our app. There's kind of three core components to our HTML layer. There's the main layout, which is going to be the shell of the page or the website itself. So it's going to be anything that's consistent on every single page, like a logo, navigation, things like that, are going to be in this HTML, as well as any JavaScript files that we're including, any style sheets, things like that. These are all going to be in this file. The HTML of the website also needs to obviously prompt with some kind of form to allow the user to log in or register. And then it needs to show that big search title box with an add button. And then if I'm logged in and I've previously added movies to my list, it needs to display that list. And because we're using Bootstrap, we don't have to worry about like spending a whole lot of time messing with our style sheets and tweaking fonts and buttons and things like that, because we can rely on Bootstrap to know that it's just going to look pretty decent, like right off the bat. So the first thing we're going to need to do is create a couple folders for our project. So let me go back here. So if we have that, we're going to want to make a public folder, or no, a views folder. And let's see what else we need. Inside there, we're going to need a layouts folder. So we're inside our views folder. We can see we have a layouts folder. And sometimes what I like to do, if I know that I'm going to be creating like 3 files, it's easy in Linux, unlike on a Mac or something, you can just use the touch command. So we're going to, let's see what files we need. We need index, which is going to be our home page. We need login, which is going to be our login form. And then inside the layouts, we're going to need the main dot. I can't see the bottom of the screen here. Let's see. Okay, so there's our main handlebars file, which is in the layouts folder, and then our 2 other handlebars files, which is in the main views folder. So let's take a look at that over here. So first we'll open up the main layout file. Obviously it's blank. So what we're going to do is pop some HTML in there. And so this is basically the HTML for our main layout. And let me move it over a little bit so I can try and get everything in there. So really all this file is doing is it's your standard HTML type file. It's got some style sheets at the top. Specifically, we're pulling in Bootstrap's style sheets right from their CDN, so we don't even have to worry about like creating those files or pulling them down or anything. And we're also pulling jQuery, the actual jQuery client JavaScript library, right in from its CDN as well. Or I should say jQuery UI's style sheet. You can see further down at the bottom, we are pulling in jQuery. We're also pulling in jQuery UI, which is what we're going to use for that sort of drop down in the title box when we do a search. And then the last script file that we're using here is just a public scripts file, which is like our own script file that we're going to use for anything that we need to do on the client. The actual design or layout of the website is fairly minimal, so there really isn't anything other than this container class and an H1 at the top, which would kind of serve as our logo. So every page that we were going to add would always have this sort of movie queue logo at the top. This body thing here, this sort of mustache-looking thing, is just a handlebars convention that this is, because this is a layout file, body is going to be where the HTML content for any of our other pages is actually inserted. So you can effectively assume that this body little tag here will go away, and a big chunk of HTML will be put in for each page that's rendered. And this is our entire layout file, so there's not a whole lot here. And you pretty much can do, we've got a couple little custom styles at the top for some things that we sort of, decided to make look pretty or whatever. But largely this is kind of an empty file. Now if we look at our index.html file, let's take a look at that real quick. So this file, this index page, you can see because it's not wrapped in any kind of HTML, we know that this is going to be injected inside of a layout. This does two things. The first block of HTML you see at the top here is where the main search text box form appears. So we've got our form with our action and our method and all of those things. The action corresponds one-to-one with a route endpoint that we've created in our routes file. So basically what this form is saying is when you hit the submit button on this form, you're going to do a post against the /movie endpoint. And if we double check back on our routes, you can see that we in fact have a post route defined for /movie that's expecting to use the controller's add movie function. So basically anybody that uses this form and they fill out the input text title field and they press the submit button, they're going to post that data to that endpoint, and ultimately that data is going to be consumable by the controller's add movie function. And we'll go into that. So with this whole top half of the page is just a simple HTML form that has two input fields. One is a text box, one is actually a hidden field, and we'll talk about why that hidden field is there in just a minute. And then besides the actual input text field, which is important, is a button. And if you take a look, you can see there's sort of some weird classes being defined in our button, and those are actually Bootstrap specific classes. So we're telling the button to use Bootstrap's BTN class, which is for button. We're telling it it's a large button. Default is going to be the color that we want to use because they have a number of different colors. And then we're telling it to be a block level button so that it's not as wide as the text inside of it, but it's actually as wide as the container it is inside. So with this top half of the HTML page being the form, the bottom half is going to be the actual movies that a user has previously added to their sort of collection. And here we're using a handlebars each loop, and basically we're looping over every movie that's in a user's collection, and we're just outputting the same repeated chunk of HTML, which is kind of just a way to display the movie poster image, the title of the movie, some votes and averages and things like that, an overview of the movie. All of these values are coming directly from the data that we're pulling from the API and storing in the database as a user adds each movie. So this is pretty much the home page HTML defined. You've got your form at the top, and then you've got your row or your rows of movies in your collection at the bottom. The last file we need to make HTML-wise is our login file. So let's take a look at that real quick. And this is pretty much going to be the same thing. It's going to be another form. You can see at the top its action is login and its method is post. So again, if we look, that corresponds directly with our route that we have defined. So anything that gets posted to /login is going to be handled by the controller's process login function. And here again, this is just pretty much an input field for email address, password, and a button to submit it. And that's pretty much it. Again, I kind of broken out the HTML in a way that makes it a little bit more easy for you to see it on a screen like this. I wouldn't normally have my input fields stacked in like a large vertical column like that, but I think it just makes it a little more readable for this type of presentation. So we've got all of our HTML defined at this point. Really, it's just 2 pages, both of which are wrapped by the same main layout. And that main layout just defines the styles, and it defines the JavaScript code that's going to be available via the browser on every page as we need it. So now the most important part. We've got this, pretty HTML, sort of pretty HTML site that works. Our servers are serving up. Well, they're actually not serving up yet, because that's the problem. We have these HTML files, but they're not actually being rendered. We haven't told our controller yet what to do, how to get these HTML files and actually render them, pass data to them, and push them up to the browser. So let's just do a quick sort of summary of what our logic needs to do. We need to be able to let a user insert a movie into their collection, and the data that they're inserting we're actually getting from a third-party API. We need to be able to get a user's list of movies that they've previously added, and then subsequently we need to allow a user to be able to click a simple link that's just like a checkbox that basically says, yes, I've watched this. And that marking that movie as watched is going to update the database record and basically turn a false to a true, which is a watched field. It just starts out as false. And then when you check that little link, it just turns it to true, and it doesn't show up in the list. So let's take a look at how we're going to set up that logic. So here is our controller file, which is just kind of bootstrapped up and got like some boilerplate text in there, but it's not really doing anything. So the first thing we want to do is, let's take a look here. We want to define our index function. This index function is going to be the code that actually runs when somebody goes to just / in the website, so effectively when they load that home page. So I'm going to replace this simple send of text here with some actual code. So what this code is doing is basically when we're using Express with our routes, every route that gets hit, so whether it's / or login or whatever, this callback function that gets called as a result is always going to accept 2 parameters. The first of which is the request, so the actual request from the browser and any data that came along with it. And then the second is the response, and the response is going to be what we use to send stuff back to the browser. So if you look at our controller, every single one of the signatures for our controller functions has those same parameters. They always have request and response as the first 2. And it's pretty much an Express.js convention that they're REQ and RES like that. But you could spell them out if you wanted to, and you could literally name them whatever you want. So the first thing our index function is doing is it's basically checking to see if the user has a session variable of user ID. And if this is the first time a user is ever visiting the site, they're not going to have a session, let alone a value in that session of user ID. So the first thing we do is we just redirect them to the login endpoint. And the login endpoint just displays that HTML login form. If they do have a user ID in their session, we're going to fall into this else. And the else is basically going to define the logic for our home page. And it's really, all it's doing is it's building a query against our MongoDB collection, and it's querying that data and returning the data to our HTML page. So you can see here we're defining a filter as basically we want all records in our collection where the user ID matches the currently logged in user, and where it's a movie they haven't watched yet, because we don't want to show them a list of every single movie they've ever had. We just want to show them the ones they have not seen yet. Furthermore, we'd like to sort those data, the result of that query, in descending release date order. So basically the most recent movies, or I think it's the oldest movies that are out first, are at the top of the list. I could be saying that wrong. So here is now we're actually going to start using that MongoDB client module that we created earlier. And because we have this handy DB function that just returns that connection, that's all we have to do is just refer to the DB. And then with that connection, we can just start interfacing with the database right away. So we basically tell our connection that we want to work with the collection movies. And again, the awesome thing with MongoDB is I'd never touched anything with the MongoDB database. I just started the server on my machine, and then I just started referencing database names and collection names as if they exist. And even if they don't, MongoDB is just going to create them for you automatically. So here we're saying in our movie queue database, which we have defined earlier in our server file, we want to work with the movies collection. So we're telling the database connection to use the movies collection, and then we're going to do a find against that collection. And the find is going to use our filter variable, which we defined right up here earlier, as well as pass along any options. The resulting data that comes back from that find, we want to just convert to an array. And our toArray accepts a callback function, which the function's second parameter is going to be the array of movies that came back from that collection. And basically that movies array, we are going to send to our HTML handlebars view model, or the HTML handlebars page, which we're calling a view. The beauty of like handlebars and really any view rendering engine in Node.js is that all of your HTML pages can optionally accept like a pure JavaScript data object, and that data object is how you're referring to fields in the HTML file when you're displaying dynamic text. So here we're basically telling our response that we want to render an HTML page. The name of our page is index, and again, we don't have to specify the extension because when we configured our server earlier, we defined it as all of our views are going to be handlebars views. So it knows that it's going to look for an index.handlebars file, and it knows where to look because we defined the location of our views, again, earlier in our configure module. When we render this index.handlebars file, we just want to pass in a data object that consists of an object with a property of movies, and that property has an array of whatever the data was that was returned from our query against MongoDB. So if we hop over to our index handlebars file, you can see here that we're doing an each against the movies property, and then each property of that is going to have each of these fields that you see here. And again, you'll see how those fields are defined because those fields are defined directly from the data that's returned from the third-party API that we're consuming. So let's take a look at this again. So here's our index file. Again, one last time, the really important thing here is if you're not logged in, it's redirecting you to the login page. If you are logged in, it's just doing a filter against MongoDB for these two properties against the movies collection. Whatever data is returned from the find, it's going to convert to an array and pass to this function, that array. And then all we're doing with that array is rendering an HTML page, and we're handing the HTML page this sort of blob of data, which really consists of just a single property, movies, and that property contains the array of data that we're actually going to work with. If we wanted to, we can include additional information here. Like we could say, we could do that, and then over in our index file, we could maybe like up here somewhere have like an H2. And just refer to the movie title or the page title that way. And you can just build this view model to be whatever you want, and kind of like the sky's the limit at that point. The only thing you can include is functions. And if you wanted to get tricky and try and include a function, that's where you kind of go into the realm of like using helpers and handlebars. And that certainly works well in Node. It's just a little bit tricky, and that's something you'd probably need to read the documentation on to get a handle on that. So with our index file, our index controller, I should say, defined, that's pretty much all of the logic that needs to occur for the home page. So because we're kind of doing this redirect to the /login, the next thing we need to define is what does /login do. So right here we just have this show login function that doesn't really do anything. So we're going to actually put some logic in there now. And this one's actually pretty easy, because the show login doesn't really do any thinking. It just shows some HTML. So all we're going to do is just render an HTML page, which is our login.handlebars, and we're not really passing in any data because we're not displaying any dynamic information on that screen. We're literally just displaying an HTML form. That HTML form, if you recall, is going to want to post against /login. So the next obvious step is for us to be able to handle what happens when somebody posts there. So we'll blank out this process login, and let's take a look at that code. Scroll up a little bit. And so here what we're doing is pretty much kind of looks familiar to the index page. We're defining our collection. This time we're defining it against a collection for users. We're doing another find because we're trying to find the user that's trying to log in. And we're converting the results back to an array, and then we're just checking a couple things with this array. So the first thing I want to point out, up here we define a user object, and that is an object that we're just defining on the fly. We could have called it whatever we want, but it only has two properties, email and password, and those two properties are the values of those two input fields on that HTML page. So we can refer to request.body. The only reason we can refer to .body is because we're using that body parser middleware. If you recall in our configuration earlier, right here, we're basically defining body parser as a way for our requests to be able to support HTML forms as well as just raw JSON being posted. So if we jump back over here, what the body parser middleware does is any data that's submitted to an endpoint via like a form, it appends it to the request object as the body property. So here, email and password are literally the names of the two input fields. So here we have email and here we have password. And those are based on the input name fields, not ID. So sometimes I can trick you up. So basically we're saying when somebody posts the process login through that login HTML form, the first thing we want to do is just grab those two fields that they submitted and save it as a JavaScript object. Here's a pretty good example of where validation and security is completely being ignored because they could have left those fields blank. So technically a user could log in with a blank email and blank password, and that would work, as weird as that is and terrible as that sounds. So when we define this user object, then we're going to do a find on our users collection, and we're literally going to pass that object in as our actual query to MongoDB. So basically MongoDB is going to say, find me every record in the users collection where the email address equals whatever they typed in and the password equals whatever they typed in. Arguably and assumably that's only going to result in one record, which is a single user's record, because every user that provides their email address and their unique password, those two things are going to be like a unique key. We're going to convert the results to an array, and if the length of that array is 0, that means this is the first time the user's ever actually tried to log in. So we're just going to treat that as sort of like a dirty hack registration. And we're going to basically use our client, again, our database connection. We're going to refer to the user's collection, and we're just going to do an insert. And we're going to literally insert that user object verbatim. So we're inserting a new record in our user's collection that consists of email and password, and it's the values they typed in. Assuming that that insert succeeds and we don't get an error in our callback, we're going to set the request session value or variable user ID to whatever the MongoDB ID is for that particular record. So now that becomes their unique user ID or their token. So for the remainder of their session, they're logged in as that user. So if you remember back up top here on the home page, now when we do a check against their request session user ID, we're not going to redirect to login. We're going to actually try and get their movies and things like that. So back down here to process login. If we do have a count in our users array that's greater than 0, that means we found an existing user. So arguably because they got the email address and password correct and they matched, then we're just assuming that they logged in correctly. Then we're assigning the user ID that was returned in their session, and we're just bouncing back to the home page. So basically these two steps are identical to these two. The only difference is that these two are inside an insert statement. So we only redirect after we've successfully inserted the record for them. You would probably want to do a lot more error checking here, because I actually have none, because you would want to make sure you didn't get an error on inserting, and if you did, that you handled that correctly, maybe you redirect to like a 404 page or some kind of like, oops, there was an error type HTML page. So this is the gist of our process login. Again, you can see it's not really doing a whole lot of thinking. It's basically just taking the fields they put in the input fields in the HTML verbatim. It's doing a find on those values, and if it finds a user, it's just automatically logging that person in as that user. If it doesn't find a user, it's automatically inserting a record for them and then doing the same thing, logging in as them again. So at this point, the logic that we have will display the home page. It'll redirect to the login if the user is not logged in. If they are logged in, it will display their collection of movies. If the user is not logged in and they're redirected to the login page, it just displays an HTML file and is using that render function. And then finally, when somebody submits that login form, it's doing the whole login/registration type stuff. The last two endpoints we have is we need a way for them to be able to add a movie. So here we're going to replace this with some logic. So let's take a look at that real quick. Okay. And I promise I'm almost done with this crazy logic code. This is pretty much kind of like one of the more interesting endpoints that we have, because when a user goes to add a movie, they're just providing a title, but somehow we need to actually be able to get all of that data for what the movie is that they're trying to add. So two things happen. First, when a user types a movie title in the title box and they perform a search, the drop-down list that appears with suggested titles is doing two things. It's finishing the text box for them, so it's making their life a little bit easier. But it's also retrieving the unique movie ID for that particular record and saving that to the hidden input field that we had defined earlier. So when the user clicks that add button, the button on the home page, they're not submitting the title of the movie they want to add. They're actually submitting the genuine movie ID from the API. So here you can see we're referring to movie ID in the body that's being submitted back versus the title, which is that input field, because we can't really rely on title, because if they just typed half of a title or spelled it wrong, when we go to add a movie here, we'd have no way of knowing like which movie they actually meant. So we're kind of putting the onus on the user to make sure they select the correct one in that autocomplete dropdown that appears. And then we're using the request module, and this is what I was saying earlier. Anytime you really are going to make any connection to an API or any kind of other URL, really, you're probably going to be using request. And you can see that request is basically doing, you're defining the method that you want to do the request against the actual URL, which in this case is this really long, the MovieDB API URL that I'm using. And we're not submitting any data to the API because all of the data is stored in kind of this like RESTful URL path kind of schema. So we're just leaving the JSON value blank here. Second parameter in request is always going to be a callback, and that callback is going to accept an error, the response, and then the actual data object that's returned from that endpoint. So in this case, we're doing a get against a movie like search endpoint, expecting it to return an actual movie object. So we're accepting that movie object in our callback as just movie. And then we're literally using the movie collections, and we're inserting that movie that was returned from the movie database API like verbatim. The only exception here is we're adding two custom fields, which is like our own fields that we want to maintain. The first is user ID. So when we add this movie to a collection, we want to assign it to a user. And then the second, we're just assuming that the user has not watched this movie yet, otherwise they wouldn't be adding it to the list. So again, we open up a connection, or we reuse our connection to our database. We specify the movies collection. We do an insert, just like we did with our user earlier, the login user. And this time we're inserting a movie. And then in this case, I am particularly logging if we get an error back. Otherwise, I'm just redirecting right back to the home page. So if a user types in that text box and they hit add movie, it's going to post against this part here, and then it's just going to reload the page. So the movie that they added, they should see on that home page because it's going to reload the whole thing. And that's pretty much the bulk of all of the logic for our entire controller. So this is pretty much the brains of our entire app. The only thing I didn't cover down here is the watched movie section, which I can go to in just a second. So again, watched movie, it's really, all of these kind of commands against MongoDB start looking the same once you get used to them. We're using our database connection object. We're referring to the movies collection. This time we're doing an update, and the first parameter for an update is how you find the record that you're looking for. So in this case, we're saying we want to find the movie record where the user ID matches the currently logged in user, and the ID matches the ID of the movie that they click the watch link on. So if you watch like the 5th movie in your list and it has a unique ID, that's the ID that's going to come back. Here, instead of doing a body on our request, we're doing params, which is a way of accessing query string parameters. So if we look at our routes for our watched movies, we're going to do a post, but we're just going to post to the route that has the movie ID right in it. So instead of like passing a data object into the controller or anything like that, we're just putting it right into the URL. So that's how we reference that value, by saying params, and then ID is just, this could have been movie ID, it wouldn't matter. And then we can go over here and change this to movie ID. And then this *1 is just me being sort of cheap and hacky and parsing it to an int, because query string parameters come through as a string, and when I did a match against MongoDB, it's not going to find a match on that string comparison versus like an integer comparison. And then again, using MongoDB, we're just telling it to set the watched value to true, and we use set because that's the only the only field in the object that we want to update. We don't want to update the entire object. We just want to mark that one field watched as true. And then here we're using a JSON response instead of like rendering an HTML page, because the watched movie endpoint we're actually going to hit via AJAX, and I will show you that in a second. So I know we went through that controller code rather quickly because I kind of feel like I'm running out of time a little bit here, but the last step we have is the client-side JavaScript. So there's a couple things that happens here on the front end of the application that we actually need to support. Two of the most important things is that when a user types in a search for the title box, an autocomplete dropdown appears, and then the other thing is that they can just click a link and say they've watched a movie. Both of those rely heavily on AJAX. So we're going to take a look at the code for that particular thing. So let's see here, the next slide. We're going to create a public folder. So let's do that now. So again, if we just do make dir public, and then, so we've got that public folder. And if we switch over to Sublime, we're going to create a new file, and this is going to be our public JavaScript file that gets loaded in the browser. And again, if you recall, in our main layout handlebars file, we referenced that public/scripts.js at the very bottom of the page. So this really, there's two things here, and we're pretty much heavily relying on jQuery for these and jQuery UI. The first thing here is we're appending to our title text box, and we're appending the jQuery UI autocomplete functionality. And that autocomplete functionality is basically going to be, as the user types in the title of the movie, it's going to make a request against that same MovieDB API. And this time we're doing an actual like title query. So it's going to return a list of movies. And then based on that list and how autocomplete works, it's just going to list them in there. And we're basically defining that the list that results below the dropdown, the label is going to be the title of the movie that gets returned, and then the value is going to be the ID. When a user selects the actual matching title in that dropdown, we're going to autocomplete the title box for them and just fill out the title of the movie that they clicked by taking its label. And then more importantly, we're going to populate that hidden field's movie ID with the ID of the item that they selected. And that circles back to our controller when we go to add right here. we're basically referring to that hidden field, that movie ID hidden field. And just as a reminder, that is right here. So that's the hidden field that we just placed below the title text box on that home page. So let's see, where am I here? That guy. So this is our client JavaScript file. So that's pretty much how we configure the jQuery UI autocomplete, is this little block of JavaScript here. And then the next piece, which is rather small, is what happens when you click on that link that's just marked as watched. And here's where we're doing a jQuery post, which is just an AJAX post to our movie / whatever the ID is / watched. And again, this endpoint right here matches 1-for-1 with our routes here. And then that goes to our controller's watched movie endpoint, which is down here. Okay, so now we're running locally. You can see by the URL, this is running on localhost, so we'll log in as, we'll log in as a new person. So because that's the first time I've ever logged in with that combination of email address and password, I'm presented basically with a blank screen. If I do a search, you can see it kind of narrows it down. If I select a match and I hit Add Movie, if you can't tell already, Big Trouble in Little China is like one of my favorite movies ever. So that pulled all of the data from the MovieDB's API and it added it to our database. So now every time I log into this website with that combination of email and password, I'm always going to get this list. So let's say we can add Aliens because that movie is also awesome. And then we can say that, yes, I have in fact watched Big Trouble in Little China many, many times. So when I click that link, it just went away, it just faded away, and now I'm left with my new homepage. And if I refresh this homepage, that movie's never going to come back. And again, if you recall, that is a result of our controller homepage. We're always doing a filter against watched equals false. And when I marked that movie as watched, I reset the value to true. And that way, when this query reruns again, it's just not going to show up. So that's basically the application. I did a count, and the whole entire thing came in at a little less than 200 lines. The application itself took me maybe less than 2 hours to write. Most of the time was just spent sort of breaking it up into chunks that I could make easily digestible for the purposes of this talk. The next logical step is pretty much, how did I get it on that Heroku? And surprisingly, deploying to Heroku is like literally one of the easiest things you can do. Basically, all you need to do is log in and register with Heroku. They have a ton of free services. You create an app using their web-based interface, and you name it whatever you want, and it tells you if it's available or not. Once you create the app, you don't even have to specify what kind of app it is. You just as soon as you push code to it, it knows, it recognizes that it's a Node app or whatever. The first thing we're going to do when we have a Heroku app that we've created is we need a place to store we need a Mongo database somewhere, MongoDB database. So the cool thing with Heroku is that they have all of these add-ons that you can add, and all of the add-ons have free sandbox versions as well. One of the cool add-ons they offer, which is actually a separate service, is MongoLab. And MongoLab works the same way. You can create a new database, create users for the database, and pretty much do whatever you want. And you can kind of it's kind of hard to see, but you can see it gives you in the middle there a connect using the standard URI connection, and that connection string is pretty much what we would do if I'm going to switch back to my code for a second. In our server file, instead of connecting to this localhost 27017, you would just paste in the connection string that your MongoLab account gave you, and then update the username and password fields accordingly. And then that's the only configuration change you need to make to the actual application itself. So if I pasted in the MongoLab connection string right here and save this, and then I switch back over to my Heroku account. After you create an app, the next screen that it gives you is the instructions on how to basically upload your app. Now, the one dependency there is that it requires GitHub integration, basically. So if you're not comfortable with Git or you're not familiar with Git, this part can pretty much be a blocker. But if you are comfortable, you basically just initialize your project as a new Git repo. You add a new remote for Heroku, and then you just git push Heroku master instead of like git push origin master. So basically you're just pushing your master branch of your code up to Heroku, and then as soon as you do that push, your Heroku app will recognize that and pretty much spin up the application right away. And then at that moment you can load the actual project in the browser. And then the name of your project, as you can see up here, is going to be whatever you name the app.herokuapp.com. So now if I log in, it looks like it's working again. So now this is the Heroku version of my app. So the movie collection, you can see Interstellar is here because this is using a different database connection. So when I was running locally, I added the movies that I had locally, but now that I'm running in the cloud, this is actually like, real live data like on the internet for people to see. You guys are more than welcome to pull up this URL as well and log in and start adding movies and kind of playing around with that. So with all of that being said, that's pretty much all I got. That's kind of my sort of big, or small, I guess, application, rapidly prototyped in about 2 hours, I would say. With my goal was to use as few lines of JavaScript as possible.
We hope you've enjoyed this program. You can stay current and up to date by signing up for the O'Reilly Webcast newsletter and keep learning from experts online.